Alright, so today what we're going to be doing is practicing factoring. I'm going to start with part A, and we're going to show you two ways to do it. One of these ways is in your notes, which I'll put up in a second so you can copy that down. The other way is just kind of a simpler way that I'll do it if the quadratic is nice enough. So let's get into it. So we're looking at A here, x squared minus 12x plus 27 equals 0. So what we want to do is factor and then use what we call the zero product property to solve for x. Now remember, and I put up the notes again, that the zero product property says that if I have two numbers or expressions or anything you want being multiplied, and I say that's equal to 0, well then what I can say from that is either we have m has to be 0, or the n actually is 0, or they're both 0. So what this lets me do is look at two things being multiplied equal to 0 and say, okay, well, let's just look at one piece at a time. So we're greatly going to simplify things. And that's the idea behind factoring first. Remember, if we take this standard expression here, this x squared minus 12x plus 27, we see that that's in our standard form, multiplied out, simplified. But what we can do is we can factor it, turn it into two things being multiplied, and then use this property that we have. So let's give it a shot. Let's try to do it. All right, so in certain scenarios, we can kind of go a little shorter than the general way to factor here. And what I mean by that is if we have something of the form x squared, where this front piece here, the coefficient, remember coefficients are the numbers attached to the variables. The coefficient here, even though I don't write it, is 1. There's a 1 hanging out here. If that's the case, then we can skip over a little bit of this general method that we're going to show in a second. So, okay, what do? Well, we ask ourselves a few questions. Question number 1. What two numbers will multiply to get ourselves 27? To get 27. Okay. So we want to know what two numbers multiply to get this one here. All right? And it's very important that we remember that if there's a negative sign in front of the 27, so if this was a negative, then we have to include that. But it's a positive, so we don't have to think about it. So, what two numbers multiply to get 27? Well, there's a lot of them, right? There are quite a few choices. Just as an example, we could have 3 times 9. That works, right? 27 times 1, I think that's another option. But remember, what we want to do for our next question is add these two numbers in order to get this middle number here. And remember, we want to keep the negative sign. Right here, we want this negative sign. So the second question is, I need to be able to add these two numbers that I picked in the first question to get negative 12. It doesn't look like I'm going to be able to do that with the first two I picked, right? I had 3 and 9, both positive, 27 and 1. Now what you need to do then is you need to expand your possibilities of factors for 27 in order to put in negatives. And remember, two negatives multiplied makes a positive. So it's possible for us to have negatives in these two numbers here. So if we think about it, and what we could do is we could just use what we've already done. This we can think of as negative 3 times negative 9. A little parentheses here so you know what we're doing. Or we could choose negative 27 times negative 1. All of that works. They both multiply to 27. And all we have to do is just check. Take the numbers we've guessed, add them. What we'll see here is that we've stumbled upon the right answer already. Whoops. This negative 3 times negative 9, if we take those two and we add them together down here, we're going to get negative 12. put a plus, we'll do a negative 9. So if we add those together, we're going to get negative 12. Awesome. Okay, so you might be saying, all right, well, what do I do here? Well, the nice thing that we can do here is just go straight to the answer. So what we can do from there, and I'll put it up in our answer up here, is we've found that 27 is negative 3 times negative 9. So we've got that. And we know that negative 12 is negative 3 plus negative 9. So then what we can do is factor this into, so you put the factors in. We've got an x here and an x here. And all we then have to do is throw in our values. So that is negative 3 and a negative 9. And that, remember, is equal to 0. We factored it. So you might be asking yourself, well, that's a little bit of a weird step to just throw those in. How do I know that you're being truthful? Well, what I can do is, remember when we practiced simplifying before, if I see something like this, I can multiply it out and I'll see what happens. So, going down here, if we want to check ourselves, which is always a good step to do, we can take this factored form and we can go backwards. We multiply this out, and remember FOIL, first, outside, inside, last. So, I take the x, the two first things, I get an x squared. Outside, okay, well that's x times negative 9. Don't forget the negative, that's minus 9x. Now it's inside, that's the negative 3 in the x. Okay, I'll try that, that becomes negative 3x. And now last, the last piece of each of these, negative 3 times negative 9 is going to be positive 27. Now we have practiced with this before. To simplify this, what do I notice here? I notice that there's an x squared term and no others, so I'm done there. But we see that there's two terms with an x. So what can we do? We can combine those into negative 12x. All right. We still have the x squared out here. It can't combine with anything else, and our 27 here. And if we look back at the top, this is exactly what we had up here. Right here. So we did it. We factored correctly. So, are we done here? Well, not quite. What we have to do here is think about the problem. So it says, solve each of the following by factoring. So, we factored it. Good. Done the first part. Then, using the zero product property, we can solve. So, going back to our previous notes, we had that the zero product property said that if I multiply two things, numbers, expressions, functions, whatever I'm talking about here, if I multiply two of them and set it equal to 0, then either the first piece is 0, or the second piece is 0, or both of them are 0. So going back to my problem, that means that either, put a little line in here, so either x minus 3 is 0, and what we could do is just stop thinking about the whole rest of the problem. Let's just focus on this. We're saying it's possible that that first piece can be 0. So if we go back to this, this just becomes a problem of solving a linear equation, which we've done before. So if we remember how to do that, we have to get the x by itself. The only thing attached to that is this minus 3. If we remember, the opposite of subtraction is addition. So to do the opposite, we add 3 to both sides. This will give me x equals 3. This is one of my solutions. Boom. Okay, well, we've done the first case down here. Check. The second case. Okay, well, that's the second piece. That's x minus 9 is equal to 0. All right, so again, I'm going to solve a linear equation. So we should see how all this is building. when we did solve linear equations before, you might have thought, why are we doing this? Well, we did some word problems, and now we're going to use it here. So again, we have a minus 9 attached, so we need to add 9 to both sides here. If I do that, I'll get x equals 9, and look at that, my two solutions. So there we go. So, we've done those two solutions. All right, we've got x equals 3 and x equals 9. Now, if you get something like this, you're on the test, you're going through. I know you don't have that much time, but we should check ourselves. So in order to check ourselves, I brought up our calculator. We will not be needing sine of x, not in this class. Okay, so what we want to do is do a graph. All right. Well, so what do we want to graph? Well, we want to graph this original function. So remember what we did before is we tried to find zeros of functions. Remember what this says. This piece up here, this x squared minus 12x plus 27. Well, what does that say? That says this is a function. I want to know when that function is equal to 0. So what do? Well, I want to do a graph. So I put in, let's see, an x, and I'm going to raise it to the power. So I'm going to raise it to the power squared. And then what we're going to do is we're going to put a minus in, and that's 12x. And then we're going to do a plus 27. Okay. So I want to see what that graph looks like. So I'm going to drag this up a little bit so we can get a better picture of the graph. And here we go. We see that there is a picture here. It's a little hard exactly to tell what's happening, but what we can do is move it over a little bit and check this out. Our graph hits this x-axis, or equals 0, at exactly 3 right here. So you can kind of drag it along. And also 9. Now, going back to what we had, let's drag this down and check it out. We had x equals 3 right here, and x equals 9. So we did it. So graphically, we see what happened, and we did it right. All right. All right, so we did it one way, the easier way when it looks nice, but we should try the more general method that we learned in class and is in our book. So this method starts off by saying, okay, step 1, it says factor the greatest common factor from everything, the GCF here. So what that's saying is we want to look at each piece of our quadratic. So over to the side here, x squared minus 12x plus 27, and ask ourselves, is there anything in common? So we look through, we see this first term has an x, okay. The second term has an x, great, but the third term doesn't. So no x common in all three. Okay, we look at the first one, well, there's no other numbers except for 1 attached here. The second term has a 12, which means there's 2s, there's 4s, there's 3s in there, okay. The third term, well, that's got a 3, that's good, but the first term, no 3. So there's nothing in common here that I can factor out. So we're good to go for step 1. Check. Step 2 was to compute a times c. Now remember, a general one of these quadratics looks like ax squared, and you could always write this down to help yourself, plus bx plus c. So anytime you have to deal with a quadratic, you can write this down so you know what a, b, and c are. In this case, a is going to be 1, because that's the number, even though it's hidden, that's in front of here. B will be negative 12, because again, that's the number in front of here, and we want to keep that negative. And C will be 27. That's the number all by itself with no x friends. All right, so once we've done that, we need to actually compute a times c. So let's try to do that. Over here, a times c is equal to 27. So again, this gets really nice because the a is 1, but we'll need this to do this later, especially for something like b. Okay, it says compute that and find two numbers that multiply to get a times c and also add to get b. So we're not doing anything different yet. So still we want to ask ourselves, how do I take two numbers to multiply to get 27 that add to negative 12? So if you're here for the first part of the video, we found out that negative 3 times negative 9, parentheses here, is equal to 27. But also that negative 3 plus negative 9 is equal to negative 12. And that's our b. Equals b equals a times c. Great. So here's the extra tricky part. Now what we want to do is create a little table here. So we're going to create a table. All right. And in the first row, what we're going to do is put our first term here. So x squared and x squared, because that's what we have right up here. All right. So we put that in, and then what we do is we take the two numbers we used and we put them in with an x attached. And negative 9x. Okay. So the next step then is to take each column, the vertical ones, and simplify. So we're going to simplify this down. So what we see in the first one is, remember doing fractions, you can think of this like a fraction, is we see an x on the top and an x on the bottom. Now this is an x to the 1, and if we remember how to deal with exponents, what we do is we can subtract the exponents. So 2 minus 2 here minus 1 here is 1, so that leaves us with just an x to the 1 on top, and then a negative 3 hanging out on bottom. Same thing for the second column. We can cancel one of the x's, the one on bottom, left with one x on top and a negative 9. All right. And then our solution here is to take these two things and put them into factors. So part 3 then would be we take each of these two and we write them as the first thing, and then you can add the second thing even though we're subtracting here. You took the first thing, I'll keep the 1 on there just so you can see what it is, and then you take this second one and throw it up here, minus 9. And we factored. So there you go. Not too bad. The second way takes a little bit longer, I think, because this part isn't actually quite as necessary. We skip over it because there's a 1 in front of the x. That's not the same for part B, and we can try to do that one together as well. So hopefully this helped, and I'll see you guys in class.